Almost every real service is multi-tenant. One system serving many customers, and each customer's data has to stay provably separate from every other's. Here's the thing nobody tells you up front: you can't bolt this on later. Retrofitting tenant isolation into a system that wasn't built for it is a nightmare, and one missed query is a data breach. So you design for it from line one. Let's see how, and where the real safety net actually lives. Let's define it. A multi-tenant system is one deployment that serves many customers. We call them tenants, and each tenant's data must stay separate from every other's. The core discipline is brutal in its simplicity. Every single query has to be scoped to the current tenant. Miss the tenant filter on just one query, and you've got a cross-tenant leak, one customer seeing another's data. And here's why you do it from line one. Retrofit tenancy later, and you're stuck auditing every query in the entire system, hoping you didn't miss one. Build it in from the start, and it's simply how the system works. So where does the tenant come from? Not from the request. The caller's tenant is an attribute of their identity, carried inside that internal token we've been building, and it is strictly server-derived. The gateway stamps it from the authenticated user, and the client can never send it as a parameter or in the body. If tenancy came from the body, any caller could just claim to be any tenant. This is attribute-based access control, ABAC, where the tenant is just another verified claim on the actor, as trustworthy as their identity itself. Now, a crucial subtlety. The token proves the caller's tenant. That's necessary, but it is not sufficient, because the resource they're asking for has a tenant, too. So every handler rechecks. Does this specific resource actually belong to the caller's tenant? And think about the failure you're preventing. It's usually not a wrong user with a stolen token. It's a valid, properly authenticated user asking for a resource ID that happens to belong to a different tenant. The gateway can't catch that. Only the handler, holding both the actor and the resource, can. That is your real safety net. Here's that safety net in real Trellis code from the member's service. The pipeline loads the member, then calls authorize with both the actor and that resource. The check is essentially one line. The actor's tenant, pulled from the token, must equal the resource's tenant. Otherwise, it's a forbidden cross-tenant error. And then one more line that's easy to miss but matters enormously. Because a member's ID is itself sensitive, the member's service hides existence, projecting that forbidden into a plain not found. A cross-tenant probe gets the exact same answer as a genuinely missing ID. Let's dwell on that last move, because it's a lovely detail. A 403 forbidden is honest, but sometimes too honest. Telling an attacker you're forbidden also tells them the resource exists. For a sensitive identifier, say, whether a particular person is an employee, that existence is itself the leak. So hide existence projects a cross-tenant forbidden into a plain 404 not found. Now a cross-tenant probe is indistinguishable from a genuinely missing ID. The attacker learns nothing, and it's a per-resource choice. The member's service hides existence. Because a member ID is sensitive, the project service returns a normal 403 because knowing a project exists is fine. Match the response to how sensitive the ID really is. So, multi-tenancy from line one. The tenant is an attribute of the caller's identity, carried server-side in the token, never from the request. Every query is tenant-scoped, and every handler rechecks that the resource it loaded actually belongs to the caller's tenant, because the real breach is a valid user reaching the wrong tenant's data. And when the ID itself is sensitive, hide existence, so a forbidden looks exactly like a not found. Next time, we go deeper into the permission model. What happens when an allow and a deny collide, and how we defend that contract against tampering. Subscribe, and I'll see you there.